Truck swallowing sinkhole reveals Japan's difficult infrastructure problem. The sinkhole that swallowed a truck in Saitama has raised concerns about Japan's aging drainage infrastructure, especially in densely populated areas. On January 28, a 10-meter-wide sinkhole suddenly appeared at an intersection in Yoshio City, Saitama Prefecture, swallowing a 3-ton truck and its 74-year-old driver. Japanese authorities have deployed rescue forces with excavators and cranes to work continuously for many days. But the driver has not yet been found in the sinkhole. Saitama Prefecture officials said the sewer system located 10 meters below the road was eroded, causing sand and soil to flow into the pipe, creating a gap in the surrounding ground, forming a sinkhole when vehicles passed through. Saitama Prefecture's sewer system was built in 1983, with a diameter of more than 4 meters. The area where the sinkhole appeared also had a stormwater drain 2 meters deep. Water draining from the underground drains further eroded the surrounding soil, causing the hole to expand 4 times and reach a depth of 15 meters. The incident has raised concerns about Japan's underground sewer system, which has deteriorated after decades of use. Surveying and promptly repairing damage to eliminate potential risks is a difficult problem for the country's authorities. Takashi Iguchi, a geographer at the University of Tokyo, warned that sinkholes are very likely to form in Japan, because roads here are built on unconsolidated sediments. If the underground sewer system is damaged, the leaking water can wash away the sediments below, causing subsidence. In the case of the Yoshio sinkhole, the cause is believed to be organic waste in the sewers that produces hydrogen sulfide, H2S, gas that smells like rotten eggs. In bends, the flow of waste slows down, making it easier for H2S gas to form. Hiroyuki Kato, a former senior engineer at Japan's Ministry of Land, Infrastructure, Transport and Tourism, MLIT, told the Asahi, when wastewater flows through a steep slope, gaps form inside the pipe, causing H2S to be released into the air, forming sulfuric acid, H2SO4, that adheres and gradually corrodes the pipe wall, causing leaks. According to the National Institute for Land and Infrastructure Management under MLIT. Among building materials, concrete pipes are the most susceptible to damage from H2S gas. Most of Japan's public infrastructure dates from the 1960s and 1970s. During the post-World War II economic boom, with the sewer system covering a total length of about 490.000 kilometers. 7% of Japan's sewer pipes have exceeded their 50-year standard lifespan, a figure expected to rise to 40% in the next 20 years. Reiko Kuano, a professor of civil engineering at the University of Tokyo, said that checking the condition and repairing pipes deep underground has long been a challenge for Japanese authorities. The MLIT amended the Sewerage Act in 2015, requiring local governments to inspect sewers at high risk of damage at least once every 5 years. The inspections focus on concrete sewers with steep slopes and locations prone to H2S gas. By September 2024, Japan needs to inspect a total of 3.463 kilometers of pipes. According to Nikkei, a comprehensive inspection program launched in 2021 has surveyed about 1.800 kilometers of sewers after 3 years of implementation. Of these, 228 kilometers were assessed as having abnormalities, such as cracks. In fiscal 2022, Japan recorded more than 2.600 road subsidence incidents, suggesting that inspection and repair efforts have not kept pace with the deterioration of underground infrastructure. More than 1.520 incidents occurred in major cities, where sewer systems were put into use earlier than other areas. Similar incidents will occur more in the future, because underground sewers are gradually deteriorating. Little by little, many pipes are under the roads, Iguchi told CNN. Shinya Inazumi, a professor of civil engineering at the Shibora Institute of Technology, said that most of the corrosion spots that have been discovered are already at a serious stage. So Japan needs to develop methods to help solve the problem sooner. In Osaka, the city government hires a private company to manage and repair the sewer system, replacing about 55 kilometers of the 5.000 kilometers sewer network every year. To prevent waste from accumulating, we have adjusted the slope of the sewers. We also use cameras to check instead of just relying on the age of the pipes to reduce risks. An Osaka official emphasized, some localities have recently used artificial intelligence to assess the corrosion of pipes. Mr. Kato, now an associate professor at the University of Tokyo, said it is difficult to inspect sewers every 5 years under the Sewerage Act, due to a lack of financial and human resources by local authorities. Large sewer systems are located throughout the country and most cities are built on soft ground. Professor Inazumi said, "People should understand that this sinkhole is not an isolated incident. We should treat the sinkhole as a major disaster risk." According to NHK, CNN, Asahi,